right. So I want to start with this picture right here, and I want to talk about how do you find the area between two curves. Now we've already discovered, or we've already discussed how our strategy is going to be. It's going to be take the one above and subtract the one below, or take the one on the right and subtract the one on the left if I'm going with respect to the y-axis. But what you need to figure out today is how do you split up the integral if you need to split it up? How do you know you need to split it up? And how do you know whether to integrate with respect to x or y? Or does it matter? Okay, so that's what we're looking at today. All right, so I'm not going to work any of these to completion. All right, I will tell you what the answer is. They're all out there on that document I created. But what we're going to do today is talk about how to set up the integral. If you can set it up, you can integrate it. All right, it's the setup that's hard. For the setup, what I like to use is a strip. Two reasons. One, I am setting you up to be able to revolve this around an axis in Cal 2.
I'm sorry, what section is this again?
This is 6.1. Good question. 6.1. Area between two curves. So the first thing you need to know is this is not like the area between the curve and the x-axis. This is strictly the area between the two curves. And when you get the area between two curves, you're talking about the absolute area. You're not talking about net area, you're talking about absolute area. How much area, forget the sign, is between the two curves. If you need to paint it, how much square feet of paint do you need? Okay? In order to do that, that means the only boundaries that you have are the curves. So I'm going to take the blue and I'm going to highlight the parabola. This is y equals x squared minus 2. And the line, which is y equals x. What region holds water? Or is there more than one? And that blue didn't show up very well, so let me put it in orange. Maybe the orange will show up a little better. Tell me where the water will stay put.
So the key here is, the real key here is basically the axis between the two intersections.
Will it hold water here? No, it's just going to go out that way. What about here?
No.
No. Here?
No.
No, rolls out that way. Here? No. Here? Here? Here?
In between the line and
Here?
No.
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 You better listen to Audrey. What did I say are the boundaries?
The curve.
Same color as her hat. What's the only boundary?
The line.
Orange. There's nothing orange to stop the water from going that way.
Yeah, that's orange.
So it rolls right out.
That's right.
Where's the one region that is bounded by orange on all sides?
Right. Between the two intersections.
This little part in here. Does everybody see it's completely surrounded by orange? This is not area between the curve and the x-axis. This is area strictly between the two curves. My advice is draw it and color the lines that make the curves. And then look for the regions that are completely colored and surrounded so the water can't get out. Okay. Now that we've identified the region, which is harder than it seems sometimes, right? I mean, everybody but Audrey said this held water,
I didn't.
and it does not, right?
Saying.
Some of you are like, I'm not saying because I don't want to be wrong, all right? You need to get over that. It's okay to be wrong. Okay? I need to know whether I want to differentiate with respect to x or y. We choose the one that's easiest. The answer is you can go either way. It doesn't matter. You'll get the same answer. But most of the time, one of them's easy and the other one is really hard. Sometimes it makes no difference. If you're going to go with respect to x, the easiest way to figure out what's above and what's below is to draw a box. And the box, if you're going with respect to x, is vertical, which I know sounds backwards. I'm going to make it a different color. Here's my box. But the reason is because the short end of the box is the differential, right? So the short end here, isn't that a dx thing? Because vertical, that would be a y thing. So my question is, if I take this little strip and I run it from where they intersect to the other place where they intersect, do I always have the same box at the, or the same curve at the top and the same curve at the bottom of the strip? So if I draw a strip at the very beginning and then I move the strip along, everywhere I go, do I always have the line above the parabola?
Yes.
Yes. Then when I integrate this, I'm going to do line minus parabola with respect to x, because I used a box that was running this way with the short end being dx. The short end is the differential. The question is, what goes on my limits of integration? So my line is x, my parabola was x squared minus 2.
Yeah, it's where they intersect.
How do you find where they intersect? You set them equal and you solve. So yes, you're going to have a lot of algebra because you're going to have to set them equal and solve, right? So to set them equal, you get a quadratic equation, move everything to one side, 0 on the other. Hopefully you can factor. If you can't factor, what are you going to have to do? Quadratic formula. Hopefully you won't get a really nasty answer. I get x minus 2, x plus 1. Where do they intersect? 2 and -1. So where do I integrate from? -1 to 2. Done. Okay? Now, could I go with respect to y? Yes? Would it be easy?
No.
I don't know. Let's check it out and see. If I were going to go with respect to y, I'm going to take my boxes off. We can see our region again. If the x box runs vertically, which way does the y box run?
Horizontal.
Horizontal. So if I run it horizontally, like this, and I'm going to go from top to bottom, right, because that's what y does, y goes up and down. I'm going to run from top to bottom. Do you see that the short end of the box forms the differential dy? It's the short dy. Do you always have the same curve on the right side? It's the parabola, right? Now, if you're going to go with respect to y, I would have to take my equation, y equals x squared minus 2, and solve for x. So I would get x squared equals y plus 2, and then I have to take the square root. Which one is the one on the right?
The left.
The,
So the negative one.
which one?
Positive.
The positive is on the right or above. The negative is on the left or below. Up and right are positive, down and left are negative. So this side of it is the square root of y plus 2. This side of it is negative square root of y plus 2.
Where you have part of the negative with the positive.
Now I have a problem. Where's my problem? Does everybody see what the problem is? I have to split it.
But it splits it.
Why do I have to split?
Because they're two different area sections.
I always have the right side of the parabola on the right. On the left, I have the line until I get to right here. And what happens right there?
You go
Split.
into the parabola.
Right side of the parabola? Uh-oh. That's not the line. What is that? It's the left side of the parabola. So if I wanted to do it with respect to y, which I would not because it's hard, I would need to do, let's see, right side of the parabola, y plus 2, minus the line. Solving for x just gives me y dy. What would my limits of integration from here to here be? The y value of the intersection. And since it's on the line y equals x, the coordinates would be the same, but normally they would not. So this is going to go from -1 up to, where, 2? And then I would have to add to that, what would the second half of it be, this bottom half?
Can't you just do the integrand of x squared? Can you do it back on the x side? Why not?
I couldn't because it would give me this area too.
No, you just x squared. Get rid of the -2. I just want to know what it is in x squared from -1 to 2. Isn't that area?
No.
Why
It
not?
would be this area.
No, get rid of the -2, right? So you're just taking the
Minus
integrand of
2.
x squared. So it shifts the whole graph up, right, to the origin?
Oh yeah, yes, you could do it that way.
Oh.
You could shift it. But in this case, you still got to lop off that triangle shape right there.
Oh,
You've got to lop that off. And that's the problem. So what would this part down here be? It would be the right side of the parabola minus, what's the left side?
Left side's negative.
It's negative, so that gives you a double negative. With respect to y, what are my limits of integration? I need y values. What's the y value right here? You have it. It's up there. It's -2 up to, what's the y value here? Which one would you rather integrate? I know which one I'd rather integrate. I'm going for that. Does everybody see that this, yes, you should get the same answer, which by the way is 9/2. So when you're done, you should have 9/2 or 4.5. Does everybody kind of understand how to split it up? Let's look at the one next to it. So if I'm looking at the one next to it, is right here. What would you do? You would stop?
Stop, probably because I have to go away.
Looks symmetric, so I'll just hit one side, just let your head
It's
fall to the
symmetric
desk.
about the orange. Now, is it? Looks like it.
Not exactly.
Doesn't it cancel out?
This is y equals x cubed and y equals x, and Ecom is on the right track because, but what are you going to actually get? Is it going to cancel?
No, because you want total, you want.
It's going to double because it's looking for absolute area, right? So it's going to double.
You gotta try to take
You could do one and then.
You could do one and you could double. In this case, I've got, if I do with respect to x, drawing vertical, which most students have a preference for x because you're more comfortable with it. And you don't have to manipulate the equation. You don't get radicals by undoing cubes. If you do this one, then I would be having the line minus the cubic, right? Because the line is above the cubic, further away. So I would be going from 0 to 1 of x minus x cubed dx. That would give me the right half. What would the left half be? From -1 to 0, what's on, what would you do?
Minus the cubic minus the line.
Yeah,
So it's
Okay.
always the top.
top minus the bottom. Or you could do bottom minus the top further away, but then remember you need to negate the signs. Okay? So I'm going to stop there. And hopefully